polar equations. Where we get to all the interesting stuff. So everybody get your calculator out. So we're going to do a new mode. So go to mode and change to radian mode for now, and we're going to go down and change it to polar coordinates. So instead of doing parametric, we're doing polar. Okay, we're going to do some polar graphing. So, once you get here, go to y equals. What do you notice is different?
It's R.
It's R, yes. And what happens when you hit this button? You get theta instead of x or t. So choose something and plug it in. And you want to set your window up, of course. Let's do a zoom standard. So I just did R equals 6. R equals 6, yeah. So if we do something like that, theta.
That's not what I got.
And we also, if we change the window, let's say instead of theta max, let's go to 2 pi instead of just pi. So 2 pi. That's exactly. Oh, it was already 2 pi. 4 pi. Never mind.
I saw a lot.
This is just R equals theta.
What? No, that's not what do I do?
If you do a ratio. Do it, do, or maybe change your seat to grading level. There we go. Okay?
But I couldn't, it was 4 pi though.
Yeah. Oh, you can change it. No, I think it was probably set up so that T step was wrong or something. So you can start getting interesting graphs. Yeah. Yeah. So I went from 0 to 2 4 lines or 2 lines. So that's just changing your window. This is just y equals theta. Yeah. What do you think is going to happen if we start plugging in some trigs? Like sine x or sine theta. What do you think is going to happen? And I'm going to need to zoom in a little bit. So
What did you put in?
I just put sine theta. So let's go instead to say, what is the maximum of sine of theta? 1. So the biggest it's going out is 1. So I'm going to put this to maybe -2 to 2. And -2 to 2. There's sine. And let's change the window even, so maybe change it to 2 pi to 4 pi. And I want even more exactly 0.02. And you get a circle. And let's see, I'm going to go back to standard zoom. And then we change it. Instead of y equals sine theta, what do you think? What else could we do to it make more interesting?
It just sounds weird.
Okay. How about do sine of theta times cosine theta? Actually, I'm going to be all that. I'm going to make it multiply, so I'm just making it bigger. So let's say 5. So let's do 9. 9 sine theta times cosine theta. Yeah. We can do 9 times. Yeah, but 5 plus sine theta. And so you're doing tangent theta is equal to 1. Yeah. And how about this? Sine of 2 theta. Oh, almost that constant. Sometimes you just want to make it bigger, just put it some number multiplying out front.
I put that in, but I put it in wrong. I got it.
Okay. Now how about you 6 theta? And this, if I change this a little bit, and maybe change this to a smaller number, 0.05, it'll get smoother. And let's see, how about 8 cosine of 2 theta minus 1. Some of these, yes. So, I hear some excitement. Oh, or is that it? Oh. So, something we need to be familiar with is symmetry. What does symmetry mean? Yeah. So we've got 3 different types of symmetry we're going to deal with. And this should be familiar. Flip across the line, theta equals pi half. Which one is that? Yeah, if you were talking rectangular coordinates, this would be the y-axis. That's a type of symmetry. What function had y symmetry, or y-axis symmetry? Yeah. So, example of this, sine graph. The oftentimes sine graph will have, now not all sine graphs have it, but if you just have your base sine graph, you have theta equals pi half symmetry. Next one, polar axis. Which is the polar axis? Now your x-axis in rectangular. An example of things that have that, your cosine graph. And a third one, pole symmetry.
What is theta equals to polar axis?
0. So this would be theta equals 0. The pole is just like when we, in rectangular, we said it was origin symmetry. We have pole symmetry. And stuff that has that, something like this, where we have an example, A squared sine of 2 theta has pole symmetry. What? For this one? There isn't anything. It's a reverse. Remember when you talked about origin symmetry? It was if you looked at the thing upside down and upright. It was just reflected around or rotated around the pole. And tangents tend to have pole symmetry. Now, if you look at page 546 in your book, you'll see a whole list of types of graphs. They have limicons, roses, limescus, and spiral of Archimedes, and you have different equations for it. Now, we need to be able to do some of the simple stuff by hand. So, some of the more complex ones you don't necessarily need to do, but the simple things you do need to be able to do by hand. Polar graph. So let's just start with one like this. R equals a really simple one, sine of theta. So actually, let's do, sine theta, and let's just say this line right here is going to be R1. And how many lines out is that? Follow that around. This is 1. Follow it around. That'd be here. There. Okay. So we are graphing this by hand. Let's start with 0. What is sine of 0? 0. So here we'll have 0 radius. If we plug in pi 6, what is sine of pi 6? Yeah, 1/2. So let's see, what's 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. This is a 5 mark, halfway mark. So in the direction of pi 6, so I'm going to do graph in green. In the direction of pi 6, we need out half. We get a point there. We got a point here, point here. If we went to, say, pi 4, what is sine of pi 4? Root 2 over 2, what is that in the decimal approximation? .4 divided by 2, 0.7. So 0.7, so in the direction of pi 4, we're going out 0.7. So this is 5, that's 1, so it would be somewhere around here. The blue marks are just indicating this is half. Okay? If we went to pi half, what is sine of pi half? 1. So we know it goes out here. What about pi third? Root 3 over 2. What's root 3 approximately? And what's root 3 over 2 approximately? About 0.8. Yeah. So somewhere, so it would be somewhere about here. Okay, 0.9. So we're about there. In the direction of pi third. So note, we know it's going this way. And we keep going. We're getting that. Now if we went to, say, 2 pi thirds. Again, you'll say it's about 0.9 because it's a symmetry over here. If we went to there, about 0.8. Pi 6, it is 1/2. And so you can follow this all the way around. So by the time we plug in pi, so this should be a perfect circle if I drew it completely accurately. Now it's fairly easy to graph, right?
What if you went below the polar?
Okay, so let's say if we plug in 7 pi 6. What is sine of 7 pi 6? Negative root 3 over 2, which is about actually just be negative 1/2 at 7 pi 6. So 1/2 except for negative, which means we're going off the direction from here, which goes to right there. We already marked that point. And if we went to each one of these, they're going to be negative, which means they're going to go up and fill out the circle. Because remember, sine of angles bigger than 180 are negative. Sine is negative all the way down here. So therefore, when I plug an angle in here, I get a negative answer, which means it's going opposite direction. So, for example, if I went to 3 pi half, sine of 3 pi half is negative 1. So instead of here, we're going opposite direction up there. So everybody follow how we did that? Basically, we're just plugging in our values that we know, easy ones. Now, a bit more complex. Let's see if that one still not 4. How about r equals the sine of, say, 4 theta? Okay, so this gets a bit more difficult. I just do a cosine one since we did sine one before. Cosine of 4 theta. So again, this is one you should be able to do by hand. Okay. So let's see. So let's call that 1/2. So 0.5. This would be 1. 1. And again, I'll just mark these ones in blue. So 1/2 squared. Okay, so what's a nice number we can plug in? But 0. What is 4 times 0 is? 0, cosine of 0 is 1. So out in the 0 direction, we know it's at 1. Right? Now, what's another number we might plug in? Okay, pi 4. What's 4 times pi 4? Pi. Cosine of pi is? Negative 1. So, at this angle, we're going out, instead we're going the opposite direction, down here. So you get that point. Now, we need to know how to connect it, so we're going to have to plug something in between them. How about pi 12? That's what this line is. 4 times pi 12 is? Pi third. What's the cosine of pi third? 1/2. So, in the direction of this, we're going out half. 3 gets the point right there. Oh, sorry, that's too far. One out too far, right there. There we go. Is that what you're looking at? Okay. So along this line, half out, so right here. So we started here and went to there. Now, if we plug in pi 6, pi 6 times 4. 2 pi thirds? What is cosine 2 pi thirds? Negative 1/2. So in this direction, we were going negative 1/2. So right here. So we're starting here and coming around there. Now it looks like we should have a 0 somewhere between here. So how would we find where it equals 0? So somewhere between pi 6 and pi 12. Oh, this is just a guess. Because no, so we started here, we went up here, and something happened to get it over here. And it might be helpful to know what happened. Where is this going to equal 0? At pi half. What would theta have to be to get it to pi half?
Pi over 8.
Yeah, pi 8. Is pi 8 between pi 6, or pi 12 and pi 6?
Yeah.
So right in the middle. So we know it's going to go here. So we know it's going to connect like this. Down here. Out here. And now what? Let's see. Pi 4. Do you do pi 4?
Yeah.
Okay. Pi third. Cosine of 4 pi third. Negative 1/2. So we get this point.
What's 4 pi thirds?
4 pi thirds is right here. This. 4 pi thirds is right here. But because pi thirds here, we go negative 1/2, we go here. We're coming out here and curving back in. And if we went to the middle one up here, we'd also get there. What if we plug in pi 12? Or 5 pi 12? Times 4? 20 pi over 12. 5 pi over 3. What is the cosine of 5 pi third? 5 pi third, right here. 1/2.
Oh, yeah.
So, in this direction, we are 1/2 out. So from here, coming out to there, if we plug in pi half, what are we going to get? 2 pi, cosine 2 pi? 1. We get the point there. So that's coming out here. Probably too far out there. Now you can see the pattern we're getting as we're going around. And we keep plugging stuff in, and eventually we're going to get the what you see on there. And we're going to keep going around as far as we need. Now, it's unlikely I'd do one like this one that has so many branches. More likely I'd do one with 3 branches or maybe 4 at most. But how many branches does this have? 8? Yeah, 8. So very likely, very unlikely on the test you get one that has 8 branches like this. But it's probably a 3 branch or 4 branch would be fine. Because this one you have to do very fine control to get all the little parts. Make sense? So do you understand how we're doing this, plugging it in? After we're graphing something a little different from these, just this simple one, r equals theta. Okay, you remember what that shape looks like, right? So let's see, I'm going to make this one 1, 2, 3. Okay, let's graph it. If you plug in 0, what do you get? 0. If you plug in pi half, what is pi half to the decimal approximate? If we plug in pi half, about 1.5. So let's see, it would be about 1.6. So a little bit more than there. So pi 4 as a decimal. 0.8, so let's see, pi 4 is this line, so about there, somewhere there. Okay, if we plug in 3 pi 4. Okay, so 2 is there, so 2.4, so a little bit further out. If we plug in pi, what is pi? Don't you dare plug in your calculator. Okay, 3.14. Okay, this was at 2. I can start seeing the pattern. That's going up. By the time we get around to 2 pi, we're going to be about 6.2. Oh, if you have it, I mean, if we just did this point and this point, you'd have, how do we get from here to here? You probably want to put something in there. So it's enough to get the picture. You notice these are curves. All of them, if you look at the diagram there, all of them are gentle curves. You don't have any that are straight lines. Let's see, anything else we need to add? Doesn't look like it.